All right. Hello, namaste, and welcome everyone. Welcome to this problem solving session. Uh, this is probably our last problem solving session, and I think perhaps after this, you guys will be having some final exam. so, uh, okay, so this is today we will be basically discussing contents of week 12, right? So, let me write that down. This is week 12, and the main focus of week 12 was basically combining everything that we have learned. And basically week 12 was, in a sense, a portrayal of ways in which you can handle different tasks. Okay, so maybe you can think of it as a prelude to how modern day machine learning systems work. So, and the focus was on basically the encoder decoder models. Encoder decoder models, right? And it also had something called attention, but yeah, attention is just a fancy term for something which is very simple, right? Okay, yeah. So yeah, so as I said, that this week's material was, you might feel that okay, we have learned several things through the course of uh, this course, right? Uh, for example, we learned about artificial neural networks, yeah, simple feed-forward networks. We learned about CNNs. We learned about RNNs last week. Apart from this, we also learned about autoencoders, encoders, and stuff like dimensionality reduction, reduction, right? So a lot of stuff, and in some sense this week's content was culmination, or mixture of all these things. How do all these things work in synergy for a given task? All right, so what is the main sort of uh, overview of encoder decoder models? It's actually quite simple. Okay, so imagine that you have some task at hand. Okay, and the basic idea is to, you are given some input. Okay, you have some input. Okay, some input, right? There is a encoder model, right? Which basically encodes this information that is there in this input, right? So it takes as input what I mean. This encoder model will take something as input. Okay, and in some sense it will output something which is, summary of this input. Okay, so some sort of summary S. Okay, then this summary is fed to a decoder model, right? So there is a decoder model which takes this summary as input, and then it outputs something which is, I mean, some output depends on what the task is, right? So so this is like the encoder, and this is like your decoder, right? So like, I mean, all the architectures that are mentioned in this week are all like this, right? Like, I think all of them can be can be made to fit in this particular category. Okay, all right. So what are like some examples of this encoder decoder model? There are several applications. Okay, for example, uh, so applications, right? Applications. So, for example, it can be machine translation, yeah, where let's say you want to convert, let's say, some English text into French, or some French text into English, right? So you need to translate French sentence into to an English sentence. So that is like, you want to take as input a French sentence. Okay, so basically it will take some French sentence as input. Okay, it will encode it, give you some summary out of it. Okay, so something. I don't know French, so I don't can't give you answer, some example, but okay, it gives you some summary. Then it is fed to a decoder model. The decoder model tries to decode, okay, given that this is the summary of your input sentence, what should be the appropriate translation that is there. So maybe some English sentence will be will be your output, okay, something like that. Another example could be of uh, let's say some uh, video classification, right? Video classification. So in video classification, you have a sequence of images, right? A video can be looked into as a sequence of images, right? So those sequence of images are fed to your encoder, and your encoder summarizes those sequence of images, and then the decoder has the task to classify it as into one of the categories. For example, let's say is the video of is the video funny or not, for example, right? Or is the video horror or not? I mean, there can be several classifications, right? So the decoder will be forced to learn something like some semantics of the summary, and using, like, sorry, the encoder will be forced to learn some semantics of the video image sequences, and the decoder will basically take this summary and classify whether the given video is of one of the class or not, something like that, right? Other example, there can be several examples, right? So another example could be image question answering, right? Image Q&A. Let's give me this. So in image Q&A, you have two inputs. One is an image and another is a question. Okay. So it's a kind of multimodal input. By multimodal, I mean that the input is not restricted to either image or text. It is both image and text. Okay. And using these things as input, you are asked to so some question is asked related to this given image, and you have to generate an answer, right? So that answer, so basically the idea is, again, you encode these two information, right? You encode the image and the sentence or the question that is being asked and summarize it. That summary is passed to a decoder, right? And that decoder will give you some output which will be your answer. So I don't know if my screen was visible in between or not. Like, I pointed few things, but I'm not sure if that was visible or not. Can you confirm once?
Yes, visible.
Okay, just a second. I think I'm connected to. So just a second. You might face some lag right now. Okay. So I think there is some issue with Wi-Fi. I'm not sure what. Uh, Pardon. Just give me a second. Okay. Okay, fine. If it works, it works, right? Let it be. All right. So I think it's visible now. Okay, fine. All right. So yeah. So this is the gist of it, right? So basically, whenever you have some sequence of inputs or multimodal inputs or something like that, encoder decoder structure helps you. Okay, and and the architecture of encoder and decoder depends on the particular task, right? So for example, the machine translation, your encoder is an RNN, right? Because you are taking a sentence as input, and your decoder is also an RNN structure, right? I mean, because you have to decode, and I mean, basically you have to give a sentence as output. However, in video classification, right, your encoder is going to be a CNN, right? It is going to have a CNN component. Why? Because video is nothing but sequence of images, right? So your encoder needs to have a CNN kind of architecture because it has to deal with images, and we know that CNNs are the architecture that you go for when you are dealing with images, right? However, the decoder here is nothing but a simple artificial neural network, right? A feed forward network which will take the summary as input and give a softmax probabilities, right? Here, in third case, when you are dealing with image question answering, right, your encoder, sorry, your encoder is basically a CNN plus an RNN, right? Why is it CNN plus RNN? Because your input is, okay, people are joining. Yeah, why is it CNN plus RNN? Because your image, you are giving an image as input. So that part, so the image part is handled by the CNN. However, there is also a question that is being asked, and that question is actually a sentence. And we know that sentences are dealt with RNN. So you need both CNN and RNN in your architecture to deal with image question answering, right? However, when you are decoding, you don't. So your the output of your decoder is nothing but a sentence. So if you are dealing with a sentence, all you need is just an RNN. So RNN is all you need, or something like that. LSTMGRU, whatever. So this is the, I mean, so I hope I am able to give you a picture that different application demand different architecture for encoders and decoders, right? It depends on what kind of architecture you are using. So it depends on what application you are trying to solve, and I mean the architecture will be specific to that application, right? So okay, some question, go ahead.
Yeah, if you could please, you took these three examples or applications. If you could also quickly
Mhm.
summarize the encoder and decoder for the others, that'll be great. The others that are given
uh,
in this.
okay. All right. So, can you name a few? I mean, the ones in which you have some issue, because I will have to look at this thing, this entire slides. Actually, there are a lot of slides. So, can you let me know a few of
Like
them which you think are?
a textual entailment would be similar to machine translation.
Yeah, yeah, definitely. Yeah. Okay. So maybe I will write it down. So fourth one is textual entailment. Okay.
And image captioning.
Yeah. Yeah, okay. Fifth is image captioning. Image. So by the way, I'm writing stuff on this iPad. Is it visible, right? This is visible. There's no
Yes.
issue there.
Yeah. Yeah.
Okay. Because on my screen somehow there is a lot of lag, but okay. If it is fine from your side, I think it should be okay. Cool. Okay. Anything else?
Um, I guess so. I think these were the ones which I can maybe just remember, recall also from the ones that are mentioned in the assignment. And
Okay. Yeah.
there was also a question related to hierarchical encoder decoder network. So if you could take an example of that also,
All right. So yeah. So a hierarchical.
or maybe we can that is in
Hierarch
question 7, if that could be done. Some-
Sorry. Can you? Oh, I missed what you were saying.
Yeah, that hierarchical one was in question 7, or maybe when we come to question 7, it will be covered.
Okay. Yeah. Yeah. All right. So, okay, so if you want me to explain all these things, can you also uh, tell? So it would be useful if you can, point out the question that you want me to solve, so that we will be well inside time, or maybe it is possible that we will go beyond the time and it will be a long video. So
Uh,
maybe
yeah,
if
first question, and
okay,
then if you could like briefly just go through attention mechanism, because from the slides it was not very clear, so that's why question 8 and 9 um, I could not
okay,
really
so
make.
189, okay,
If just seeing again, and also in 3 and 4 they're basically, for machine translation or image questioning, they're asking which formulae. So is it expected that we remember that, or the way you're summarizing that would be sufficient to answer that, because the equations that are there, or these function calls
Uh,
type, that's a little
yeah, yeah.
confusing.
So maybe for the exams, maybe I think it is good to remember this. I mean, it's not tough. I mean, so what I explained was, a broad overview that everything falls in this category. However, I think it is better if you remember the exact things. Like it's not difficult because there is a pattern across all the tasks. Uh, I mean, whenever you see that okay the output is actually the encoder is actually using an RNN, you should what the formula is, because it won't change with application, because RNN operates in similar way across tasks. Okay, like stuff like that. So maybe it's kind of, I think you should remember,
Okay.
right? So okay, so these are the questions and these are okay, fine, right? Okay, so let me start. So maybe I will explain, take few more examples and explain these things. Okay. So, so for textual entailment, I hope you know what textual entailment is. Textual entailment is the idea in textual entailment is that you are given. So the idea is as so the textual entailment in some sense is like reasoning. Okay, for example, uh, what can we say? So the one example that was given in slides was that it is raining outside. Okay, so this is a premise. So what is the logical conclusion of this premise? The logical conclusion is that the ground is wet. Okay, I mean that if it is raining outside, it means that the ground will be wet, right? Because water is falling on it and stuff like that. So your output is basically a hypothesis that given this premise, what is the expected outcome? What is your hypothesis? What should happen? Something like that. So I mean, uh, Mona, do you still have some question because your hand is raised?
No, no, I forgot to put it down. But isn't it hypothesis what is given, and what the output would be the conclusion?
No. So hypothesis is, so yeah. I mean, hypothesis, you can also interpret this as conclusion. But I mean, conclusion is something that need not. So conclusion is like what? Conclusion is always true. Okay, hypothesis might not be true. There is a difference between conclusion and hypothesis. Conclusion is always something that is true. However, hypothesis is something that you guess, or you make some logic. So you can think of hypothesis as a logical conclusion. Okay, it is a special type of conclusion. Yeah. There's not a, so I mean, for the sake of this exercise, I think you can use them interchangeably. However, the hypothesis is not an input, it is the output. Okay, the input here is a premise. You are given a situation which is your input, and you have to give the network is expected to give a logical conclusion, which is the hypothesis, right? So there is a subtle difference between these two things, right? Yeah, so given this, okay, so I mean, end of the day, you are given a sentence, right? The premise is nothing but a sentence, right? It is a sequence of words, and what you are asked is also a sequence of words, right? So hypothesis is also going to be a sequence of words. So I mean, I hope you will agree that there is nothing. It is very similar to machine translation, where you are given a sentence as input, and your output is also a sentence, right? However, in machine translation, the vocabulary might not be same. Like the input vocabulary might be different from the output vocabulary. However, in textual entailment, the input and output vocabulary are the same, right? So here also, the thing is that since your input is a sentence, you can use an RNN based encoder, right? And your decoder can also be an RNN, right? Because you have to give sentences out. So that is that, right? Uh, Apart from this, let's say that next thing is maybe you can. So image captioning was one of the applications, right? So what happens in image captioning is the following, right? You are so I mean I hope you, at some point of time all of us have used uh, some sort of social media, right? Uh, so what happens there is you upload some image and you caption it. The caption is nothing but in some sense a description of the image, right? So so image captioning is a task where you give an image as input to a model, right? And you expect a caption or a description to come out as an output of the decoder, right? So what happens there? So what is the input there? I mean, here the input is going to be an image, right? And your output is going to be a sentence. I mean, it is a caption. I mean, the output is a caption. Caption is nothing but a sentence. End of the day, it is a sentence, right? It is an English sentence. So, I mean, whenever you see that your input is a image, the first thing that I mean, how can you deal with images? The first thing that should click in your mind is, your encoder should be a CNN, right? Only then can you encode an image and come up with some summary, as I mentioned here. However, with the decoder in this case, the decoder in this case is going to be what? It has to deal with sentences, right? It has to output a sentence. Uh, the only architecture that we know which deals with sentences is what RNN, right? So encoder is going to be a CNN and your decoder is going to be an RNN. Okay, so I hope this makes the things a bit clear. Okay, uh, yeah. So I mean, so whenever you are asked of stuff like this, right? You are given an application and you are asked, okay, what should be the encoder? What should be the decoder? Just write down the input and what is the type of the input? Is the input a sentence? Is the input an image, or is it both input and as well as and so guys, can you tell me if I'm audible, or I mean, was I
No, no, you were
disconnected or
not
something?
audible
Can you
for
let me?
about, yeah, you were not audible for, after you talked about image captioning. After you finished that, you were not audible. And the screen also, there was nothing, it was
Okay, I see.
visible, but no date was there. Dynamically, we could not see any.
Okay, I see. Yeah, I think there is some network issue from my side. Let me try to rejoin. Okay, please hold on a second. Right, I'm trying to rejoin. All right. So am I audible now? Uh,
Yes, you're audible.
other device? Yeah. And the screen is still shared, right? Or is it not?
Your screen is shared. The only the participants are visible.
Okay, okay. Now is the like is the text visible now?
The no, the desktop. Maybe there's a lag.
Okay.
The lag actually had
Yeah, I
increased.
think so.
Whatever your text lag was increased.
Right. So let me rejoin from my tab. Okay. I think there is some network issue at ISC. It happens a lot. I don't know why such a big institution has such puny problems. I don't know. Just hang on a sec, please. Okay, so okay, so it's connected now. Hopefully there should not be any issue. Alright, it's connected. Share screen. Okay, alright, so this is visible. Uh, yeah. Okay, so is it visible now? The text, the notes. So can you confirm, just confirm once if the notes are visible?
Yes, notes are visible. Thank you.
Okay, thank you. Yeah. All right. So sorry for the hiccup, but yeah, I don't know what is the issue, but okay. So I hope these things are clear, right? So depending on upon different applications, what should be the model of your encoder and decoder? I hope. I mean, it's just a logical conclusion basically. Okay, think of what your input type is and correspondingly think what architecture can work with a particular type of input. Okay, that should be good enough. Right. So okay. So okay. So you asked to explain hierarchical encoder decoder. So let me go over it. Okay. So okay. So Niman has raised his hand. Is there some question? Go
Hello, am
ahead.
I audible?
Yeah, yeah. You are audible.
Okay, I in the screen I think it shows that in 50% the answer is image Q and A. Is an, regarding regarding image
Sorry.
Q and A.
Sorry, can you maybe repeat your question? I'm not able to hear it clearly.
I'm asking about 50 question. Uh,
Fifth
I
question, okay.
50 question. So I gave the answer as image Q and A. The application task which is the RNN model should be used as an encoder.
Yeah.
And you
Okay.
also mentioned in your screen that image Q&A is an RNN plus CNN can be used for image Q&A things.
Image Q&A. Okay.
Uh, but
Okay,
ma,
yeah.
after submitting my assignment shows that the answer is wrong. They accepted as a answer is video capturing.
Yeah, actually the question, if you read the question carefully, it is not RNN and CNN. The question asks you about select the task for which the RNN of the CNN model should be used as the encoder. Okay, it's RNN
Oh,
of the CNN. It's not RNN and CNN. Okay,
okay,
there is different between the two sentences.
okay, so
RNN of the sequence, RNN of the CNN means that there are different CNNs, okay, and they are trained in a recurrent manner, right? So that is where this video classification will come into place, right? So you have CNN in end of the day to deal with. However, we will have the recurrent CNNs, right? So that is RNN of the CNN. Is that
okay,
clear?
The two things are different, right?
Yeah, yeah.
RNN.
These things are different. Yeah.
Different. Thank you very much.
Okay. All right. So I was discussing hierarchical encoder decoder. So here the idea is actually a very sort of it extends the idea of what the encoder decoder models are. So let me explain that. All right. So let's say you have sequence of sequences basically. So uh, the basic problem this deals with is I mean deals with uh, sequence or sequence. For example, consider something like maybe uh, uh, you can think of something like document classification, right? So document classification, I mean, for example, an example would be document classification, right? In document classification, uh, you have uh, you have sequence of sentences, right? However, these sentences themselves are sequence of words. So you can see that it is sequence of another sequence, right? So whenever you see a sequence of sequence coming into picture, you should think about hierarchical encoder decoders. What does it do? Basically, the way to deal with this is as follows, right? So there are two RNNs that play here. Okay, so this is how they work, right? So for consider the first. So let's say when I say let's say sequence of sequence, right? Consider the second sequence that I am mentioning as S1, okay, and the S2. Like there are two sequences. Okay, the first sequence is let's say like kind of sequence of words, right? Sentence sequence of words, basically a sentence. There will be an RNN on this sequence, like S1, okay, and there will be another sequence, another RNN that will be on top of this big, these smaller sequences, right? Let me explain it. Maybe that is a better explain it. Okay, so consider a first RNN. Okay, so let us see. So let's say this is like your encoder, right? This is an okay. Let me not confuse you. So let's say that there is a sequence. There is a sentence, right? For example, I love Bangalore. Okay, this is a sentence. Then there is another sequence, another sentence. Bangalore has nice weather. Okay, and maybe there is another sequence, another sentence. DLR Bangalore also has high traffic, right? Something like this. So there are three sentences. Like this is a sequence, this is a sequence, this is a sequence. However, this also this is like a sequence of sequence, right? I mean, because since like sorry, I mean, I, okay. So let me reiterate myself. Sorry. So I'm saying that this itself is a sequence of words like I love Bangalore. These are words, right? And I love Bangalore is a sequence of words. Similarly, Bangalore has nice weather. It is a sequence of words again. This is also a sequence of words. And similarly, this third sentence is also a sequence of words, right? However, if I read them together, right? This is one sentence. This is another sentence. This is third sentence, and this is a sequence of sentences, right? And sentences themselves are sequence of words. So this has a sequence kind of structure, right? Now the way to deal with such 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 types of inputs is the following. What you do is you take each of these sentences, okay, and you use an RNN to summarize each of these sentences, right? So this will give you some. Okay, so something like this. So this will give you some summary S1, right? This will give you some other summary S2. This will give you some other summary S3, right? So what each of these RNNs have done here is that they have summarized each of these sentences. What was this? Each of these sentences were nothing but sequence of words. So each of these RNN has summarized the sequence of words, right? Now you have summaries of each of these sentences, right? Or in other words, you have a sequence of summaries now. So if I have to summarize this whole sequence of sequence, all I need to do next is summarize these summaries, right? So how will I do that? We maybe take this below. So the way to do this is you take another RNN. Okay, there is another RNN, a bigger RNN, which takes these sequences as input. Okay, sorry, these summaries as input, and it gives you some final summary, which is, let's say, some S star, something like this. Uh, I'm not sure if I'm able to convey my point. Let me reiterate this thing again because I think I fumbled a bit. So what I'm saying is that you have a sequence of sequence for if you whenever you want to think of what does a sequence of sequence mean, think of let's say a paragraph which has multiple sentences, right? Each of these sentences is a sequence of word, right? Each of these sentences is a sequence of word. However, a paragraph is a sequence of sentences. Sentences is a sequence of words. So a paragraph is a sequence of sequence, right? The way to deal with this is that you deal with each of these sentences individually, right? So this is the first sentence. You have an RNN which summarizes it and gives S1 as output. Okay. There is this another RNN which takes this as input, another sentence as input, and gives S2 as your output. Okay. This is the second summary. This is the third sentence. This RNN again takes this sentence as input and summarizes it and gives S3 as input. Now, since you have summaries of each of these sentences, you have actually created a sequence of summaries, right? S1, S2, S3 is a sequence of summaries, right? What you have to do is now, in some sense, you want to summarize this sequence of summaries now. To do that, you create another RNN which is on top of these smaller RNNs, right? These were small RNNs. Now you have a big RNN. This RNN will now summarize each of these the sequence of summaries and gives a total summary, like a grand summary, which is S star, right? So this is how hierarchical encoder decoder works, right? So now you can now given this summary, maybe you can pass this as to some decoder network and get whatever your desired output is. So this is how hierarchical encoder decoders work, right? So if I have to maybe what was the question in related to this 8th and ninth, was it
No,
right? So
related
there was,
is
yeah,
seventh.
related to this is 7th. Okay. So 7th and 8th, right? Maybe I will just cross them because I will just explain them here itself because I have just explained hierarchical views. So 7th question says
I
that
think
we are
eight.
given, sorry,
So can we say that the encoder is many RNNs and then the decoder would be a single RNN for this sentence
uh,
sentences?
yeah, you can say that. Yeah. So in hierarchical encoder decoder, the all the game is going on the encoder side, not on the decoder side. Okay. I mean, I think if some application comes where you want to maybe give hierarchical outputs, maybe you can have a decoder which is hierarchical as well. However, uh, like I don't think that will be necessary for this for the current course. But yeah, I mean, you can have that, but I think it's better not to confuse it. I think you can safely assume that everything which is special about a hierarchical encoder decoder happens on the encoder side, not on the decoder side. Okay, right? So let's see what the seventh question is. The seventh question. Okay, so let me maybe create a new page. Yeah. So the seventh question asks that we are given a task where we have to take as input some sequence of sequences. Okay, sequences of sentences. Okay, now sentences. Whenever you see this, remember that sentence is also a sequence of words. So it is sequence of sequences. Okay, and produce a sentence as output. Okay, right? Which of the following model will work best for this task? Okay, so it's a very simple thing. So let's see all the options, right? The first is hierarchical encoder decoder. So this is the correct option. Hierarchical encoder decoder. So this is the correct option. However, let's see what the other options are and why they are not why they are not correct. So LSTM, right? So LSTM can take sequence a sentence as input. However, it cannot take sequence of sentence as input, right? Because I mean, the way LSTM is constructed, it is not designed to take a sequence of sentence. It can only take a sentence as input at a time. So this is not correct. Okay. What is C option? C option is encoder decoder model with single RNN encoder and single RNN decoder. Okay, let me just write single RNN. So the encoder is a single RNN and decoder is a single RNN. So this will also not work, right? I mean, end of the day, you have to. So I mean, if LSTMs cannot deal with a sequence of sentences, a single RNN can also not deal with a single sequence of sentences, right? So this is also not correct because you will again won't be able to manage the sequence of sequence structure, right? And the D option is encoder decoder models with RNN as encoder and encoder decoder model with RNN as encoder and decoder equipped with attention mechanism. So encoder is again an RNN and decoder has some attention. So okay, I mean again, you won't be able to deal with a sequence with RNNs, right? So this is also not the correct option. So seventh question, I hope if there is some doubt, maybe you can directly unmute yourself. If not, I mean I will move forward. Yeah. So let's see what the eighth question is. Eighth question is saying that we are using hierarchical encoder decoder network for document summarization task. What is the number of levels at which we need to implement the attention mechanism? Right. So remember that. Okay, I mean we have not seen attention yet, but I hope you have read about it. So okay, so hierarchical encoder decoder. Just maybe keep in mind this thing, right? So this example had two hierarchies, right? This was the first hierarchy, and this was the second hierarchy, right? You can think of hierarchy as level of abstraction. So this was a big paragraph, right? It was a big document. Now you summarized it into a smaller a smaller sequence, right? Just S1, S2, S3. Instead of dealing with sequence of sequence, which was the input, you were somehow able to construct a sequence of summaries. Okay, a normal sequence. So this was like so the first hierarchy was so you can think of this as level one, right? Level one because it was very complicated. You can think of this as level two, right? Where things became a bit simpler. So there were two levels here, right? So so in a document summarization task, you have sequence of sentences, right? Document summarization. What you have is a sequence of sentences. So I mean, and sentences is what is a sequence of words, right? Sequence of words. So, I mean, since there are like sequence, it is a sequence of sequence kind of structure. You will have two levels, right? Two levels. So even if you are applying attention or whatever, you need to deal with two levels basically. So the answer will be two. However, I mean, it is not necessary that the level will always be two. Okay, it is possible that let's say, I mean, it is possible. Just a note here, maybe style marketing star. It is possible that you have something like sequence sequence. It is possible that you have to deal with something like this. So maybe you can think of something like sequence of documents, right? Sequence of documents, right? And what are documents? Documents are sequence of sentences, right? And what are sentences? Sentences are nothing but sequence of words. So here you can see a structure which is sequence of a sequence of a sequence, right? So in this case, what you will need is actually a three level of hierarchy, three levels, right? You will first, so the idea will be that you first, yeah. So the idea will be as follows, right? So the first level will, summarize this into. You start with, okay, yeah. So the first level will deal with, summarization of this, then it will come to this, then come to this. So there will be a hierarchy like that. Similar to what I said here. Just imagine that there is another RNN here which takes S stars, sequence of S stars as input and gives something as output, right? Something like that. So maybe you can let me know if it was clear or not. If it wasn't, I can explain again. Otherwise, we'll move forward, right? Okay. Okay, cool. So these things are done. Let me see. Seventh, eighth are done. Maybe I can see what third and fourth question are because I think they are simpler. One, three, and four, right? Okay, so I will explain what. So maybe I will take first one, three, and four, and then move forward, right? Okay. So let me see what one, three, and four are. So first question is what? If we make it asks you that if we make make the vocabulary for an encoder decoder model using the given sentence, what will be the size of the vocabulary? So what is the sentence? The sentence is encoder decoder decoder models are used to perform language translation tasks. Okay, so let us count the number of words here, right? So this is one, this is two, this is three, four, five, six, seven, eight, nine, 10. Right? So there are 10 words. Okay. However, we also need to remember that in NLP you have tokens, right? So you need to have a start token here and an end token here, right? So whenever you are feeding something as something to your network, the network needs to know, okay, what, so is this the starting of a sentence or is this maybe you are picking something from middle? So that is indicated using the start token. And similarly, when you are ending a sentence, the end token is used to make sure that the network knows that, okay, this is the end of the sentence, right? So you have to take these into consideration as well. So this will be 11 and this will be 12. So there will be total 12 words in the vocabulary. So whatever, right? So if B is your vocabulary, the cardinality of that will be 12, right? So this is the answer 12, right? Let me know if there is some doubt. Otherwise, I will move forward.
I'm
So
not
let's see.
sure if start and stop was mentioned in the slides, so I'll check again. So
I think it was mentioned.
okay,
You can
check
have
again.
a look at it.
Yeah.
Yeah. Maybe with some other words, maybe not end, maybe stop words, something like that. But it was mentioned. Yeah.
Okay, I'll check again. Thank you.
Yeah. So let's see what the third question is. The third question is saying that we are performing the task of machine translation. Okay, using an encoder decoder model, choose the equation representing the encoder model, right? So when you are having a machine translation, just what do you need to remember first is, what is the input? It is a sentence, right? And what is your output? Output is also going to be a sentence, right? Because you are translating a sentence into some other language. Okay. So sentence, you need to deal whenever you are dealing with sentence, you need to use an RNN, right? So we are asked about the RNN on the encoder side, right? Okay, so let's see. So basically, so let's see the options. Basically, let's see what are the options, right? The first option is what S naught is equal to CNN of xi. Well, I mean, we know that, CNN, we cannot use CNNs to deal with sentences. So this is obviously discarded, right? Okay, let's see what the B option is. So the B option is saying that S naught is equal to RNN of ST minus 1, comma, E of Y hat T minus 1. Okay. So, so by the way, I hope you remember what is S naught, right? So S naught was the summary that I was talking about. So maybe I can draw a small figure here. So you have a sentence that goes here as input, right? Uh, a sentence that goes here. So maybe some input that goes here as input, right? Uh, Something like that, and gives some S naught as output. Then this S naught is for further given as input to the decoder, right? So this is actually this is the equation for decoder side. If you see this thing, right? So I mean, this is not the equation that is used for the encoder side. This is the equation that is used for the decoder side. So on the decoder side, what happens is that let's say you have this model which gets S naught as input, right? It will have some yeah, so it won't have something anything as input, but it will give some y naught hat as output. Okay, and the same model is used again. So y naught here is again given as input, and this thing is, so s1 is given as input to the second step, right? So y1 hat is given as input. Similarly, this goes on, right? So something like this will happen. So s2 will go here, and you will have y2 hat as output. This will go on, right? So here you can see that ST is what some RNN. RNN is your model. It is a function of RNN of whatever the previous activations were, right? So ST minus one. Uh, so from the previous time step, you are getting some activation, which is ST minus one, and you are also using the y hats of the previous. So you are also using the prediction from the previous time step to create your current activation. So it will be y t minus 1 hat, right? So e of y t minus 1 hat is just, saying that uh, which embedding is it, right? So like, I mean, which word is it? So that's not a big deal. It's, I mean, the same thing, right? So this is the decoder side input. How this is not the encoder side input. So this is not the encoder side equation. I mean, even if you don't remember, you can see what the equation is telling you and think that, okay, is this is this making sense or not? Basically, right? Okay. I mean, another thing to, straightforward discard this is that, I mean, encoder side has to take inputs, right? There is no input. I mean, YT minus one hat is like output of a decoder. ST minus one is some activation. However, I mean, the encoder has to take something as input first, right? If I cannot see some or xt minus one as input here, I mean, like definitely it's not the encoder side, right? So that on that ground also you can discard this option. Third option is basically S naught is equal to RNN of HT minus 1 XIT. So what is this saying? This is saying basically that like you have something as input, right? You get some S. So it is saying that you are getting some HT minus 1 as input here, right? And you are also getting some XIT as input here. And you are using that to create some HT, right? And maybe then you are using, again, giving this to XIT plus 1, giving HT plus 1, and something like this, right? So this does look like an RNN model, right? So I mean, what is happening here is that, and maybe I will erase everything and redraw it. So what it is saying is that, okay, you have some network, right? At each time step, you have some xi uh, 0, I maybe something like this. Maybe let me just check. It's x1, some x2, x3 is going as input, right? And you have a recurrent model here, which takes like some h naught as input, right? And it is creating h1. It is giving h1 the first at first time step. It gives h1 as output, and it is feed to the next time step h2 as output. It is also taking x2 as input, by the way, here. H2 and X3 is given as input here to this model, and it is moves forward, and eventually it will give what it is supposed to give S naught as output, right? So maybe some Xn is given here, and here like Hn minus 1 will be given here, right? Something like this. So here we can see that S naught here, this one is nothing but whatever your RNN model is, like this whole RNN model, yeah, of what it takes hn minus 1 or ht minus 1, whatever word you want to use, and xt or xit as input here, right? So this is a correct expression for your summary basically, right? So this does make sense. So I think this is the correct answer, right? C is the correct answer. And fourth option is again it is just taking the input as input. So like if you see, look at the D option. It is saying that S naught is what? S naught is nothing but RNN of XIT, right? So by this logic, I mean, what it is saying is that, okay, you have an entire encoder, right? However, the only whatever is like the last time step is taken as input, and it gives S naught. However, this is not what we want in an RNN, right? We want what X1, X2, these things to be accommodated as well. That those things are not missing here. Those things are missing here, right? So those information also need to be accommodated. So this is again incorrect, right? So I hope I am able to explain these things in detail to to. I mean, even if you don't remember the equations, maybe you can see what the equations are actually telling you, right? Maybe that way it is better to, you can actually see if that thing makes sense or not. So let's see what the fourth question is. So third question is done, right? Where was it? Okay, so third question is done. Let's see what the fourth. Oh, first question was also done, right? Yeah. Let's see what the fourth question is. So the fourth question is saying that, okay, we are performing the task of image question answering, right? So it's okay. So this is image question answering, right? Okay. Using the encoder decoder model, choose the equation representing the decoder model for this task. Okay, so again, whenever you are given a task, write what the input and the output is, right? So input is going to be what? An image plus a sentence, right? So this is managed by a CNN. This will be managed by an RNN, right? Okay. And what is the output that we want? Output is an answer, right? What we need as output is an answer, which is again a sentence, right? Which is again a sentence. So a sentence has to be, if we want to deal with a sentence output, we need to use the RNN, right? Okay. Uh, choose the okay. So image question answering. Okay, so I think here the answering is related to this thing. Uh, I think it's like a classification task that we are dealing with here. Okay, so I think uh, in uh, uh, in the slides, the image question answering, by answering what we mean is actually a classification. Okay, so I mean it's up to us. Like I mean it is possible that I mean the answer can be classification. It can also be a sentence. I mean it is up to us. Like nowadays sentence is a lot more famous than classification. I mean given an image you can ask several things like, okay, Can you describe the image and things like that? However, I think that is capture that will come into. Okay, fine. Okay, I mean we will go by the slides basically. I think the quiz is based on the slides, so we will go by the slides. So I think in the slides, the image question and answering is actually referring to classification task. Okay, all right. So what will happen here is the following, right? So basically, what you will be given is that. So how does an image question answering encoder work? So you have an image, right? Some input image I. You basically pass it through a CNN model, right? CNN model to get some summary of it, right? Let's say SI. Okay. Then you have a question as well, right? A question is nothing but a sentence. So it will have some x1, x2 till some xt as input, right? So you give your RNN, SI is fed as activation to the first network, and x1 is just fed at the first time, right? So this will generate S1. Sorry, maybe I think the proper word to use here will be H naught, right? Because on the decoder side, encoder side, we are using H as the activation. On the decoder side, we are using S as the activation. Okay, so H naught is given as input here. It will generate some H1 and X2 will be given as input at the second time step, and similarly it will follow, right, until the last time step. So this will give some ht minus 1 as input, xt will be given as output, and it will give some s naught, right? So like you can think of this thing as this whole thing as your encoder, right? So this is your encoder here, right? Okay. Now given this encoder, right, you have generated a summary s naught, right? Now you have to just do a classification task, right? So s naught, what will be s naught? S naught will be like a vector, right? Some Rn vector. All so now just to since you have to do a classification task, what you can do is you can pass it through a feed forward network, a single layer network, right? You pass it through this, like I mean, I hope you know how to do it, and you give some softmax probabilities, right? Some probabilities as output. So this operation is equivalent to doing a matrix multiplication, right? So if the weights are B and you have your activation as S naught, right? B S naught plus B will be your affine transformation, and then you apply softmax to it, right? This will be your like probabilities, right? And this will give you what? This will give you some probability of the output, okay? Given what? Given uh, whatever your question was, this was your question, right? This was your question q, given q and I. So q and I was given as input here, right? So q and I are given as input. This is your encoder model that gives s naught as output, and s naught then is passed through a simple feed forward network, which is your decoder in this case, and that gives you some softmax probabilities, and this which denotes your probabilities. Okay. So I think the C option is correct. So let me know if this is clear or not. Was I not clear, or maybe I missed you somewhere? If you have some doubt.
This is fine. And could you just then, so the third example that you took in the beginning in the application, that
Okay.
was image questioning. So there we had said the encoder was your CNN plus RNN. And so
Yeah.
in this questioning, are we saying the answer is a sentence or it is
Yeah.
uh,
This is for a sentence. Yeah.
classification?
Maybe I should. Yeah. Yeah. So maybe I should maybe specify her answer is actually a sentence, right? However, so this is what this is here. Okay. Maybe these two things are wrong. If your answer is actually a classification task, right? Classification task, then your decoder will change to a ANN, right? Simple artificial neural network. This is how it will change. Uh, is this clear? I don't know.
Then, yes, yes, it's clear. And then you'll use softmax like the example we just saw.
Yeah. So yeah, I mean nowadays actually this classification no one does it. So I assume that in the slides it is answer is your actually a sentence. However, I mean I hope you are not afraid of the answers being a sentence now because you know how to deal with it, right? You just use another RNN, right? So you take the summary, use an RNN to give some sentence as an answer, right? So I hope you are not afraid of that. I mean that is also straightforward. Like from now, I mean you should be able to deal with everything, like whatever kind of input it is you should be able to deal with it. And go stepwise, just see what the input is, what the input type is, what architectures can handle such a input type. Okay, and then create an encoder based on that, get the summary, and then see what your desired output is. If your desired output is a classification task like this, you just need a neural network, right? Simple neural network. However, if your decoder, your output was an answer where the answer was actually a sentence, you could have used a RNN instead, right? And that would have worked as well. Yeah.
Okay.
So, right. So, if that is clear, I think the fourth one is done here, right? So let's see what the ninth question is. Ninth question is saying that we implement an attention mechanism for images for the output of one of the layers of CNN. Which layer output should we use to implement our attention mechanism for best result? Okay, so maybe I will brief something about what attention is. Okay, so I think my handwriting is very bad for some reason. Okay, cool. Okay, so maybe switch some colors. Okay, good. Okay, so let's see what attention is. I mean, it's again a very simple task. It's not anything, it's a simple thing. It's not. It's actually just an extension of what the summarization that we are doing till now. Okay, so till now what we saw was the following, right? So the idea was that there is some input, right? Some input is given. Okay, just let me clean this pencil a bit. Right. And what we did was, given this input, we said that okay, here is the summary S naught, right? And this S naught is given as input to this decoder model, right? And this decoder model is expected to give some output, right? Something like this is happening. Encoder, this is a decoder. Something like this is happening. So, I mean, I hope you can see that, we are saying that everything, this entire input can be summarized using S naught is what we are seeing end of the day, right? However, I mean, in many cases, for example, in translation, I mean, is this how our human mind doesn't work like this? Okay. I mean, it's not that if I say some sentence in English, you will be summarize the entire sentence and then translate it, right? You will focus on the local words, right? I mean, uh, I don't want to use two languages here, but yeah, I hope you get the feeling, right? I mean, if you want to uh, translate some sentence uh, like Bangalore has a nice weather, something like this. And if I maybe ask you to translate into maybe Hindi, so this entire, so I mean, the first sentence will be like Bangalore, right? To start with, so to decide that okay, the first word is going to be Bangalore, you don't need this entire sentence to decide that okay, the first word is going to be Bangalore. All you need to know is that okay, what is the noun here? The noun here is Bangalore. Okay, so Bangalore is going to be Bangalore. And similarly you can construct the entire sentence. And I hope you will agree that for each sentence, for each word that you will generate, it's not like the whole sentence is required to generate this particular word. Only a particular part of this sentence, maybe these last two words are used to generate some particular word and things like that, right? So that is the motivation behind attention mechanism. What it does is the following, right? So So instead of saying that, okay, the entire summary is here in S naught, what it says is the following, right? It says that, okay, so let's say you have a encoder model, maybe I will, something like this is there, and you have you have these RNN structures here, right? Something like this, right? You are getting some X1, X2, X3, X4, uh, X5 till some XT. So you are giving something like this as input. So this is some H naught. This is some H1, right? This is H2, H3, H4, something like this is there, and this is HT minus one, right? And you have a decoder model, right? Okay. So this decoder model, uh, let's say it. So maybe it takes gives some S naught as output. This S naught is given here as input, right? Okay. S naught is given as input, but again the decoder has an RNN kind of structure, right? Something like this, something like this, something like this, and maybe it will finally give you some output, right? Something like this is happening. Okay, yeah. So what we are saying here is that in ideal scenario, right? So S naught will go as output. You will give some Y naught hat. That Y naught hat is again given as input, and some S1 is given here as input, and you move forward some similarly. However, what attention proposes is the following, right? It says that, okay, since the first output here, Y naught hat, does need not depend on this entire summary S naught. It is possible that it is possible that I might require only like summary of, let's say, maybe X1, X2, and X3 to generate Y naught hat. So what it does is the following. It says that, okay, instead of taking this entire summary S naught, what I will do is I will take a weighted average of H naught, these intermediate activations, H naught, H1, things like that. So what it is saying is the following, right? So it is saying that, okay, I will multiply H naught with some alpha naught, I will multiply H1 with some alpha 1, I will multiply H2 with some alpha 2, and similarly I will multiply ht minus 1 with some alpha t minus 1. Okay, and I will take a weighted average, right, and give that as input here. I hope you are getting my point, right? What we are saying is that this entire summary S naught of this, all the inputs are might not be necessary. So what I am saying is that instead of giving equal weightage to each of these input X naught, X1, X3, which is what S naught has done eventually, right? S naught has summarized the entire sentence. However, it is possible that all you need is summary of, let's say, first three words. But how do I learn this thing that, okay, I have to give weight to only first three words? So what I will do is I will introduce some parameters alpha naught, alpha 1, alpha 2 till alpha t minus 1, and I will multiply alpha naught with H naught, alpha 1 with H1, alpha 2 with H2, alpha t minus 1 with Ht minus 1, and take a average of them, a weighted average of them. Okay, and I will give that weighted average as input to the this first encoder model, first time step RNA. Okay. Similarly, I will do that for the second time step, right? Some here. For similarly for third time step here. For each time step, the values of this alpha naught, alpha 1, alpha 2, alpha t minus 1 will change. Okay. Depending upon which time step I am trying to predict. So this will be some y1 hat, will be some y2 hat, right? Some y3 hat. It will depending on which time step I am trying to predict, the value of these weighting coefficients will change. So in some sense what we are doing is that for generating a output at a particular time step, I am saying that, okay, my weights will decide that, okay, where should I focus. Like there is a long sentence, okay, this is the big sentence. It is possible that I need to only concentrate on these three words. If that is the case, my weighting factors alpha 1, alpha 2, alpha 3 will become very high and the rest of them will become very small. If that happens, my inductive bias is actually helping me, right? I mean, I hope I am able to convey my point why attention is, important, or how why it works. However, this is fine for sentences, right? I mean, sentences, you can create these word embeddings and do these things. However, consider an image, right? For an image, there is a attention. I mean, I mean, it doesn't make sense to pass it through a, let's say, if I pass it through a CNN model, some CNN model, and get some features, right? I mean, it doesn't make sense. How do I apply my attention here, right? I mean, attention has to. I hope you will agree that in case of uh, images, the attention would be something like this, right? I need to focus here, or I need to focus at this part of the image, this part of the image. How do I come up with that? That is the question here. So to do that, what we do is the following, right? What we do is we pass it through a CNN. Okay, we pass it through a CNN. Okay, and extract a particular intermediate layer. Okay, so CNN has a lot of layers. Maybe extract a particular layer. Okay, output of a particular layer. So maybe the output of that is like maybe like something like 10 cross 10 cross 10 cross 10 cross 32, something like this, perhaps, right? I mean, that is the feature, that is the size dimension of the feature that I have extracted. Now next what you can do is you can think of this as 100 vectors, right? These are 10 cross 10 is 100, like 100 vectors of size 32. So you can think that, okay, there are 32 vectors, each of them are like 32 dimension, and there are 100 such vectors, right? These are 100. You can think of this in this way. And then you can apply attention here, right? You can say that, okay, maybe only these three features are something that I want to put more weight on, or maybe this is the feature that I want to put more weight on. How does it correspond to this thing that I just explained here? If you remember, the way CNNs work is the following, right? I mean, it has a sparse structure. Like if this is your input image, it applies kernel here, right? I mean, this is how it works, right? So if you remember the CNN lectures, what it said was, after particular time step, if this is my feature, right? Actually, this part of the image will be actually corresponding to a bigger part of the original image, right? Something like this. Okay, I think I ruined it, but yeah, I hope I'm able to. Yes. So I mean, if you remember the lectures of CNN, we learned there that if you pass it the image through several layers, a small part of the uh, a small part of the feature at a particular layer corresponds to a big part of the original image, because that is how CNNs are constructed. And if I am using that, and if I'm using those vectors here to apply attention, I hope you will agree that maybe what I'm doing is I am actually focusing on this part of the image, which corresponds to some 10 or 3 vectors of this particular feature, something like that, right? So that is how it is applied in images. How that is how attention is applied in images. Okay. And for the given question, this ninth question, right? What we have been said is that we want to implement attention mechanism for images for the output of one of the layers of CNN. Which layers output should we use to implement our attention, right? So let us see at the options. The first is fully connected layer. Fully connected layer. I hope you will agree that fully connected layers will give you a vector as output, right? So here what we are saying is that you have a vector as output. However, as I said here, right, that I mean earlier I had made a diagram here, that vector doesn't convey the spatial structure, right? I mean, vectors are like vectors won't convey, that okay, this is the part of the image that is maybe something, and this is the part of the image where I should focus on. Vectors are just a representation of the entire image. However, it doesn't have that spatial information in it. So I mean, this is not what is desired, right? So this is not uh, desired. The B option is saying that max pooling layer, max pooling layer. Again, max pooling layer, basically what it will do is, just uh, take the max of a particular patch and give that as output. That is also not desired, right? I mean, what I want to do is not, I don't want to max pool. I mean, I want to retain those spatial information, right? So that is also not desired. So C option is saying that, CNN layer, which has spatial information. I mean, this is correct option because I mean that is what we want, right? We want to get the spatial information. So I mean, end of the day, I want to do something like this, right? Okay, I want to say that okay, this is important, this is important, this is important. Only a particular, only those layers of a CNN which have the spatial information in it can give me that information, and I can use those to apply attention. So this is the correct option. So C will be the correct option, right? So yeah, so I hope I was clear, or if it is not clear, maybe you can ask questions if I lost you or something like that. Because this is what I think this was the last question that you had asked to solve. So ninth question is also done. Yeah, I think six questions are done. So yeah, majority of them are done. So maybe you can, someone can unmute themselves and let me know if there is any more question, or maybe if we can stop here. Yeah. Or if something was not clear, you can ask that as well. I can explain again. So, okay, silence. Uh, all right. So can I assume that there are no more questions?
Can you just give me a minute? I'm just checking, please.
Yeah, sure. Yeah, so I hope the course has been, in some sense, maybe painful, but you feel, you might feel that you have learned something, or I don't know. Maybe you can also give some feedback if you want regarding the problem solving session.
The problem solving sections have been very helpful. It's a very good way to understand. And I missed the initial one, so I'm going to go back and see the recordings.
Okay.
Yeah, thanks so much.
Yeah. Yeah, sure. All right. So yeah. So yeah. I mean, there are other questions. We can take them. Yeah. So I mean, if you have some general doubt, I mean, regarding deep learning in general, that also you can ask. I don't have any issue answering them. Yeah.
Could you share your email ID if it's okay?
So okay. So maybe I will put it in chat rather. Okay. Yeah. So this is the email ID if you want to reach out. Right. All right. So, so I hope so this was the last lecture. We won't be having any more problem solving sessions. Okay, so I think this is the last time we are meeting, right? So I wish you best of luck for your exams. I hope you perform well, and I hope these yes, I hope these lectures turn out to be useful for you, right? Yeah, if there are if there is some particular feedback regarding my sessions, if I fumble a lot or maybe I am not clear at times, you can tell me. That those things are most appreciated. Uh, yeah, if not, I think yeah, we can end this session and we can
So
yeah.
Piyush, where you have the recording YouTube link? Could you provide here, please?
Yeah, I thought that these things are shared, but okay, let me share it again. Uh, I don't know. Have you have they have? I think there is a Excel sheet that is shared. I'm not sure though.
No, I just joined few last session, so I don't know how
It's
that is.
there in the, if you go to the course, I'm just going through, navigating through it so I can tell you, just give me a minute. In that, just give me a minute. There, the bottom somewhere it says live sessions and all,
Yeah,
and there's
yeah,
to
yeah.
Excel sheet, and there they
So
have a table, and there you can get it.
yeah, so maybe I will share the screen and show you, right? Okay. So I hope the screen is visible, right? So this is your a regular deep learning portal, right? NPTEL portal. Here you can can someone confirm if this is visible or not? I don't know.
It was
Is
visible,
the
but
screen?
then you are again back to the screen.
Yeah, yeah,
Yeah, now
yeah. So is the yeah okay. So here you can see some problem solving session is written, right? So you need to go here, okay, in the
got it.
problem solving session. So I think my internet is not working or something because it's very slow. Yeah. So here you can click here. So a Google Sheet will open up. So this sheet has actually all the lectures and links to all these lectures. Yeah. So here you can see. So corresponding to Piyush Tiwari, you have the lecture. So video links and all those things are there. Yeah. So
I
these are
just
the
shared
video
the link
links.
to the sheet. I think it'll just ask you to connect through your registered ID. I think that's how it'll work.
Yeah, maybe. I don't know. That is possible. So once you open this, so here you can see these lectures, or else I have shared this link in the yeah chat as well. Yeah, so Mona has shared this sheet
Yeah, I
link as
got
well.
it. I got it. I thank you very much. Yeah, I got it. Thanks.
So, all right, guys. So have a nice evening and best of luck for your exams and yeah. So yeah,
Thank
Thanks
have
so
a
you.
nice
much.
evening.
It was
Bye bye.
very helpful. Good luck to you too for your future.
Thank you.
Yeah, thanks. Okay.